I'm Devaki, working as an associate professor in Siddhartha Institutions, Puttur. Today, I'm going to explain the concept stacks in data structures. First, we know what is a data structure. Data structure is nothing but the arrangement of data in computer's memory. That means organization of data in the computer's memory is called as a data structure. Now, data structures are classified into two types, linear data structures and non-linear data structures. Linear data structures are divided into four types, arrays, queues, stacks, linked list. And non-linear data structures divided into two types, trees and graphs. Now first we see what are the linear data structures and non-linear data structures. So linear data structures are nothing but the elements are arranged in the linear order. That means sequential order. That means all the elements are arranged in one after the another. So here arrays, stacks, queues, linked list, all these are the examples of the linear data structures. Next, coming to the non-linear data structures. So in non-linear data structures, the elements are stored in the random order. That means all the elements are not placed in the linear order. So these data structures are called as non-linear data structures. So here trees and graphs, these are the examples of the non-linear data structures. Next, we see what is an array. So here array is a collection of homogeneous data elements in which all the elements are stored in consecutive memory locations. That means array can store only the same type of data elements, and array can arrange all the elements in a sequential order. That's why array is a linear data structure. It can store the elements one after the another. Here, this is the representation of the array. So here, A is the array name, and the elements are stored in the subscripts, that is F0, F1, F2, F3, F4, like that. The first element of the array starts with the index, that is 0, and the next element of the array starts with the index, that is 1, that is F1. Next element of the array stored at the index of 2. So like this, all the elements are stored in the memory locations. And we can access the array elements by using subscripts. So this is the representation of the array. Now coming to the stacks. Stack is a linear data structure. So here in which insertions and deletions can be done only at one end. That end is called as top of the stack. So array can store the elements, and array can store all the elements in the sequential order, and insertion and deletion operations, these operations can be performed only at one end. So this is the definition of the stack. So the top element is called as the topmost element of the stack. So here array follows the LIFO structure. LIFO means last in, first out structure. Which element that is inserted at last, that is to be deleted at first. So here the special name for the insertion operation is push, and the special name for the deletion operation is pop. So first we want to push an element 1 onto the top of the stack. So here push 1 onto the top of the stack. So 1 is element inserted at the top position. Next, if you want to insert the element 2 at the top of the stack, then 2 is inserted at next. So 2 is at the top of the stack. So like this, we are inserted 1 to 5 elements into the top of the stack. Next, coming to the stack operations, push, pop, is empty, is full, count, change, display are the all are the operations of the stack. So here, suppose coming to the push operation, suppose whenever you want to insert an element into the top of the stack, we use push operation. Suppose we want to delete an element from the stack, we use pop operation. Suppose we want to determine the stack is empty or not, then we use is empty operation. Suppose we want to determine the stack is full or not, then we use is full operation. Suppose we want to find the total number of elements present in the stack, then we use count operation. Suppose we want to change the position of the element in the stack, then we use change function. Suppose we want to display the elements, what are the elements available in the stack, then we go for display operation. So now see what is the procedure we are following to push an element into the stack. So before inserting an element into the top of the stack, first we have to check the stack is full or not. Suppose if the stack is full, then the overflow condition occurs. And we can initialize the top value of the stack is -1. Then we check the stack is empty or not. Suppose if the stack is empty, then we increment the top value is by 1. So after incrementation, top becomes -1 plus 1, top becomes 1. Now we have to insert the new element onto the top of the stack. So like this, we have to insert the elements until we reach the maximum size of the stack. So this is about the procedure of push an element onto the top of the stack. So these are the push operations, push representations of the stack. So here initially stack is empty. So that's why top is pointing to the top value is -1. So now you want to push an element onto the top of the stack, that is 10. Now first you have to increment the top value by 1. So -1 plus 1 becomes 0. Now top is pointing to the 0 position. Now you are inserted the element 10 onto the top of the stack and top is pointing to the position that is 0. Suppose again if you want to insert the element onto the top of the stack, then we have to increment the top pointer by 1. Then the 20 is inserted at the top position, that is 1. So like this, you have to insert 1 by 1 element. So now you are inserted the 10 to 40 elements. Now the stack is full. That means we reached the maximum size of the stack. This is about the push operation. Now coming to the pop operation, before going to pop the element from the stack, first we check whether the stack is empty or not. Suppose if we try to delete the element from the empty stack, then the underflow condition will occur. If the stack is not empty, then first we have to access the first element of the stack, that means the top element of the stack. So once pop operation is performed, then top is decremented by 1, that is top equal to top -1. So this is the procedure we are following to delete the element from the stack. Now these are the representations of the pop operation. Now initially the stack is full, it contains 10 to 40 elements. So this is a 0 for first, second and third element. So that's why top value is equal to 3. So now I want to delete the element 40 from the stack. So here I pop the element, that is 40. Now top is pointing to the second position, that is 30. So here top is decremented by 1. So again I want to delete the top element, that is 30 from the top of the stack. Now I deleted the element, I removed the element. Now top is pointing to the 1. So like this, we have to delete one by one element from the top of the stack. So at last, now all the elements are deleted. Now the stack is empty. So now top value is equal to -1. This is the pop operation. Thank you.